Good morning. I hope you're doing well. It's always a bit of a bad rush right at the very end. I thought I had heaps of time beforehand. I was ready way in advance, but the last like 10, 15 minutes just really snuck up on me then. But yeah, I hope you're doing well. I'm doing very well. This week was at times a very frustrating week. There were some kind of annoying things that were kind of annoying, but we'll get there when we get there. And thankfully, the TLDR is that everything is good now. Well, yeah, mostly everything is good now. There's no like big problems lurking in the background that I'm kind of daunting running into again, which is nice. Um, yeah, cool. All right, so let's get into it. So the first thing for this week is that I found the timing bug from last week. So last week we were trying to get a little dropper to drop one of the balls down into the hand, and this was only using the hand. So I lined up this tripod that you can see behind me, like perfectly directly over Jugglebot, and so that way we could just leave all of the legs off, and then drop the ball in, and the hand should catch the ball. But there was a timing issue there where I had to add in an offset, and that offset I referred to as a dirty offset, and the only reason why we actually needed that in the end was because I'm a goose, and because I can't remember my maths very well, and I wasn't paying attention to my equations. So the root cause here was that the equation for the time taken for a ball to fall from rest, so if you're dropping the ball from a height and it's just falling down, is this equation. T is square root of 2h on g. If instead we are throwing the ball from the ground and it's going up and then back down again, it follows this equation, 8h on g. And care to guess which one I used in my code? That's correct. It's the 8h on g, because I'm a fool. Yep. I just wasn't careful enough when I was looking at my equations. So how this happened is that I have a notebook here where I'm doing a lot of my like working out for various things, and I have a page where there's a lot of this sort of like projectile motion sort of stuff. And I had this equation here. I saw, yep, cool, T is square root of 8h on g, done, easy, let's move forward. Without realizing the context that that equation was in is for the ball to go up and down. So yes, very silly mistake, and yeah, should not have really happened if I was paying attention. The promising thing about this is that you may remember from last week that the offset that I applied was just under 400 milliseconds. It was like 370 something, I think. And that was just from me like qualitatively looking at the records, at the logs, and being like, okay, it looks like the ball hits like 370 milliseconds before it's supposed to, so I'm going to put that as the offset. So it's very qualitative. If we look at what this equation, what the difference in the air time is of the ball from being thrown up to the height that I was dropping it at versus just being dropped, it's like 320 milliseconds. So I feel pretty good that this was the reason why I had to like subtract that time, because we were just subtracting the time that it took the ball to fly up in the first place. So that kind of makes sense. Unfortunately, well, for better or worse, I haven't thoroughly tested this yet, but we'll get into why soon. So I'm pretty sure this is the error, but I haven't actually been able to confirm that it is. So before I realized that I only realized that was the mistake like 2 days ago, but before that, I was very aware of the fact that lining up this dropper so that it's perfectly over Jugglebot's hand is such a pain in the ass. It took me like a good half an hour to do that the first time, and it's so easy to bump the tripod when it's there, and that was just not tenable as a long-term solution. So if that's too tedious, well, we've got this whole 6-degree freedom platform that can move around into any position. Why don't we just use that to position the hand to be directly under where the ball is going to drop? Right? We should be able to do that. Right? Until we get DC bus overcurrent errors. And this is where our gremlin has returned. So you may remember from, this was a while ago, I think this was last year even. There it is. We had this problem where I was getting the ball. I was setting up a system where I could throw. Yes, Harrison time, nice. I was setting up a system where I could throw a ball over to Jugglebot and it would just move, and not try to catch, but it would just kind of move the platform so that it like intercepts the ball. And we had this problem come up a few times where, let me get rid of me. It went over, in this case it missed, but then the leg collapsed. And it was very weird. It would always like try to push up a little bit and then it would just give out and collapse. And I would get this DC bus overcurrent error. And this happened a few times in various scenarios. And I was chalking it up to maybe this was because in that position, you can see that the platform is in a fairly, it's very much leaning towards that leg that collapsed. So I was thinking that like maybe there's just so much weight from the platform on there that it's just making the whole thing collapse. Like it actually can't push enough. I was not super sold on that hypothesis though, because these legs are very strong and they should easily be able to, like each one should easily be able to lift up the platform, especially at the speeds that it's moving at by itself. So like, I really don't think that would be an issue. But I had no idea what it was. And it was only happening in that one specific situation where it was like over in that side and like, yeah. But now it's back again. And it's been happening very often. Increasingly often, it would happen. But it was really weird. So I want to kind of walk you through. This was like a good day and a half, I think, of trying to figure out what the heck was going on here. As a bit of a spoiler, actually no, I don't want to show you my spoiler yet. But I made a new way of controlling Jugglebots that I can kind of move it around, similar to the Space Mouse, but without the Space Mouse, using something different. And I found that I would get this DC bus overcurrent error when I was controlling it with this other way, but when I would control it with the Space Mouse way, I would get no errors. Until all of a sudden, after I did this like maybe 5 or 10 times, I started getting the errors when I was doing the Space Mouse control. And I was like, this is weird. I wasn't getting the errors before, but now I am. And this is just like moving it around in like, I don't know, normal-ish sort of like circles and tilting around and everything. And then the more that I tested this, eventually it started getting this error after the platform would just raise up to the middle position. I'm like, this is weird. I spent so long trying to poll different, because it says DC bus over current. So it's like, okay, something is getting too much current. And so I spent ages like recording all of the different currents that were going through the bus, seeing if it's the same for all the different actuators. Keep in mind as well, this whole time it was only ever the same one leg was getting this error. I was like, this is so strange. It's just driving me mad. And eventually I was like, no, stuff it. Maybe it's the O drive. Maybe the O drive itself is cooked. And I was just kind of like hoping in the back of my mind that it's not the leg, because if the motor in the leg is broken, that's going to be a whole job to replace that. I do have spares, thankfully, but I don't really want to go in there and take apart the leg. Like, they're done. I'm done dealing with that. Don't want to do that again. So I'm like, okay, maybe it's the O drive. Hopefully it's the O drive. So I have a couple spare O drive Pros, and I swapped out a fresh one. I'm like, cool, maybe this will fix the problem. But it did not. And so much back and forth. The problem ended up being the cables were unplugged. I actually encountered at one point, once I replaced the O drive with a fresh one, I encountered, when I was getting it to do like its calibration sequence, I got an error saying unbalanced phases, which from my understanding means that the O drive is not there are three like electrical phases in the motor, and it should detect that they're all equally resistive. And if it doesn't detect that they're all the same, then it throws this unbalanced phases error. And I was getting that error, and I'm like, hang on, this is weird. I checked the docs for that error, and it says, check your wiring, make sure that it's all good. And I had a look around, and all of the wiring that I could see looked fine. But I forgot that these barrel plug things were inside this cable sheath. I just completely forgot that connection is even there. So I didn't think about that for ages, till eventually I'm like, no, something is weird here. And I was really, at that point I was thinking it was the motor that was broken, and I did some more testing. And then eventually I pulled back the sheath and I'm like, oh, that's right, these connections are also here still. Or in this case, they're not. So yeah, this blue one had completely unplugged. The yellow one was fairly out. Somehow the red one managed to stay in. But yeah, they were a bit messy. And at the time I was talking through all of this with John, and he was helping me run through some diagnostics. And he asked if there were any signs of like spot welding from these pins. And you can actually kind of see the first inkling of it right on the corner there. But it's pretty nuts. Like, these wires must have just contacted and lost contact a couple times, and they've actually like properly burnt themselves. Like, that's crazy. And the worst part is, and perhaps probably unsurprisingly, this was not the only actuator that this was happening to. There were two more where the wires were starting to kind of work their way out. So, in my mind, there's a couple different ways to kind of resolve this issue. One would be to just cut the wires and solder them the whole way through, so that it's just one continuous wire the whole, like from the motor to the plug. I'm a little bit hesitant to do that because I'm fairly sure that eventually I'm probably going to want to I don't know. I'm in the habit for the last couple of years. I've built a version of Jugglebot and then had to recycle it and use the same parts for the next version of Jugglebot. I don't think that we'll be using these exact same motors for the next version of Jugglebot, but it's a possibility and I might want to use them somewhere else. So I'm hesitant to like cut them and permanently modify them to suit this specific need. To be honest, that's probably not too likely at this point. I think it would be a shame, I think, to pull this version of Jugglebot apart, given that this is the first version that's like actually kind of working. But to be honest, when I found this problem yesterday, I did not want to go through the effort of cutting all the wires and soldering them all together, especially because all of the wires are like the perfect length right now. So if I cut them, I'm going to have to get new wires and it'll just be a whole thing. So the easiest solution that I could think of was to just cover the connections completely in another layer of heat shrink. And hopefully this will stop them from pulling apart. You want to know what the really funny thing about all this is? I had already done that on two of the actuators. Why did I don't know what I was thinking in the past, but at some point, last time I did the wiring for these, I guess I did 4 of them, and then by the time I got to 5 and 6, I was thinking, maybe I guess I should cover these so they can't pull apart, and then just couldn't be bothered to go back and do the other 4, I guess. I don't know, I have no recollection of doing that. So I was kind of onto something, but not really aware of it enough to do it for all of them, which I should have done. But yes, so hopefully this is fixed now. And I don't think that these can pull apart now. You can see like this red one does have a bit of a dimple in the middle there, but that was just because I was testing how well it held that connection while the heat shrink was still hot, so it kind of flexed a little bit. But now that it's cool, like after they cooled down, I gave them a good tug and they seemed pretty fine. So finally, that was a massive pain in the butt, but at least it's gone now, and that error is not happening anymore. And yeah, I'm glad to have this be gone, because this problem has just been kind of lurking in the back of my mind since it started happening. When I was doing the catch testing, ever since then, for like the last like month or two, it's just been in the back of my mind like this is going to come back at some point. Whatever's causing this error, you don't know what it is, and it's going to be here. Thankfully, it's done now. So yes, moving forward. To address some comments, Saif says, would it be alright if you somehow make a course explaining and teaching everything you learned while doing your work? Yes, I very much intend to do this. You said I'm willing to buy it. I'm not really a big fan of making things closed source, as, I don't know, close followers of this project may be aware. But I absolutely have the intention at some point. It's a tricky thing of like, there's always progress to be made, but then I have a lot to present from like the last main video that I made, sort of thing. It's a tricky balance between like, I don't know, teaching about what I've done versus continuing what I'm doing to get it to a further point. But rest assured that I absolutely have the intention of, once this is somewhat capable, I want to make a video series explaining everything about how this works, like the whole thing. And obviously that's not going to be everyone's cup of tea, but there's not really much content about that online, and that's what's making it so hard for me to do this, is that I can't like see how it's actually supposed to be done, and like a working example of this like theory applied to practice. Yeah, so yeah, I absolutely have the intention of doing that. When that will be, I don't know. I probably want to get the robot to be doing like multiple balls pretty happily before I feel that it's at a stage where it's worth kind of showing how it works. But yeah, that will come eventually, and it will be free. It'll just be on YouTube. So I don't know, watch this space, I guess, and be patient. And Lola says, hi from Poland. Hi from Australia. Cool. All right. So now the platform can move the hand to where it needs to be, right? Right? Not quite. Well, Maybe. We'll see. So to test this out, this is where my new method of control comes in. So in order for the platform to move so that the hand is underneath the ball, we basically need to set up a routine where the cameras, the motion capture cameras, will track a ball, and the platform just stays like it's so that its Z coordinate is directly underneath. To test that out, rather than forcing myself to walk back around, because like that corner over there is the only spot that I can really stand where I'm out of the way of the cameras, except for where I am right now. And so that I didn't have to walk around there all the time, I made my conductor's wand. So this is just a carbon fiber rod with a tracking marker on the end, and this way I can stand over here and move it around, and Jugglebot will follow this. And I have some strange findings from this. So let me go to... Yeah, nice. First try. How good was that? Yeah, so here we have a recording of one of the sessions of me moving this wand around. So up the top, we've got the X, Y, Z. So X and Y are in blue and red respectively. Z is in green. And then down the bottom, we've got a plot of Y versus X. So you can see like I kind of come in from the side where I'm standing over here, and then I wobble it around a bunch. I don't know if you can really see, there's a little dot that's moving around on the bottom one. I go across, and then at the end I move it out. And this all looks fine until as I was moving it around, I realized like it doesn't look like Jugglebot's like directly, it doesn't look like the hand is directly underneath the ball, like the marker. It looks like it's slightly offset. It's definitely moving around while I'm moving the marker around, but it's not perfectly lined up. And so what I did to test this out is I put one of the balls in the hand, and then used my conductor's wand to move it around, and that way I could track the ball, I could track where the hand actually is, and then track where the marker is, and kind of compare the two. And that's where we get this one. So let me get rid of me. So here we've got the red and the green are X and Y again, and then the light red and the light green are the positions of the the hand itself. So the dark colors, the more like saturated colors, are the marker, and the less saturated colors are the ball of the hand. And we can see as we move through, like the X ones get pretty close most of the time. Like they're within, I don't know, 5 millimeters of each other. When I'm moving quickly, they tend to diverge a bit, but that's just because the platform is tuned to be kind of slow. Oh no, I'm on the wrong one. Oh, I can't get rid of me. There we go. Sorry about that. Yeah, so the X ones are pretty close. As I move quickly, they kind of diverge away, but generally speaking, they're fairly close. But the green ones, the Y values, are like 60 millimeters off pretty continuously. And I honestly don't really know why this is happening. There's, yeah, a pretty big gap between the two, and I don't know why. So to give you a full picture of what is happening here, we take the raw tracking data from the motion capture cameras, and then convert that into, so that also includes the 6 markers that are on Jugglebot's base. We then use those 6 markers on Jugglebot's base. We know where those are supposed to be with respect to Jugglebot's base, and we can use that to find like a coordinate frame that is in Jugglebot's base. And that way we can say, okay, Jugglebot's base is here with respect to the motion capture origin, and now all future tracking data that we have, we can offset it, well, we can transform it to be in Jugglebot's base coordinate system. And by doing this, everything should be referenced to Jugglebot's origin. Should be. But there's an offset here, and I don't know why. Of course, both of these marker data, like the ball and the conductor wand, both of these are being processed in the exact same way. So I'm skeptical that this difference that we're seeing is a result of that transformation process. I don't think it's that, but I have no idea what it could be. It's kind of weird. Yeah, I mean, really, it just means that the platform is not where I think it is with respect to the base. But unfortunately, right now, I don't have any trackers on the platform, so I can't actually confirm that or not. But more on that later. Yes. So it's not quite lining up perfectly. However, I'm no stranger to dirty offsets. So now I just have in my code just offset by whatever. Like I just sifted through a bunch of data that was very similar to what I just showed you then, and just kind of found like an average difference that they were, especially when they were stationary. So I actually, to actually get this offset, I put one ball in the gripper, in the dropper, one ball in the hand, and then just let it sit there for a bit, and then I just saw how far off they were, and then just adjusted that offset until they were pretty close to each other. And now it's within like a millimeter or two, I think, which is pretty good. But there's still that offset there. Like that's just a hard-coded value, and I have no idea if that's going to change over time. Like I haven't moved Jugglebot since then, so it's potential that if I just like rotate the base, I actually did move the base this morning, so maybe it'll be completely off today. Let's find out. But yeah, it's very not stable right now, and I'm not really sure what's causing that. So one follow-on from this is that I mentioned I think 2 weeks ago, that because Jugglebot's coordinate system here and the motion capture coordinate system here, because those are rotated with respect to each other, I needed to then apply, after doing this transformation between the motion capture coordinate system and Jugglebot's coordinate system, the base coordinate system at least, after doing that, I said, because these are different, I have to apply an additional rotation to line them up properly. But that's not how the transformation works. The transformation does do that. In reality, this coordinate system is like completely off of what the motion capture camera one is. And by doing this transformation, it already does that rotation by itself. So I don't actually need to do that. And the reason, like how I found this out, is that while I was using my conductor's wand to move Jugglebot around, I was like, hang on, I'm moving the wand, say, forwards, and Jugglebot's moving like to the right. It was like perfectly 90 degrees out of sync with what I was doing. So all I had to do was go back into my code and delete that rotation part. But this does raise questions in my mind about why I was getting the strange movements that I was getting before that led me to believe that I needed to have this rotation in the first place. Those strange movements were when I was doing the ball throwing. So I was tossing a ball to Jugglebot and it was moving to try to catch it, same as the clip that I showed before. But I was getting really weird behavior out of it, where it looked like it was doing everything correctly, except that it was just rotated by 90 degrees. And for some reason, after I applied that 90-degree rotation, that fixed that problem, mostly. It's kind of hard to tell, because even when that like tossing and catching worked, it was still kind of sketchy. Like it was never perfectly bang on, and the ball would always bounce around a bit. So it's kind of hard to tell what was actually going on there, because it wasn't really precise enough for me to see exactly what it was trying to do. But yeah, I don't know what was happening there. I will absolutely, eventually, hopefully soon, return back to throwing the ball and having Jugglebot catch. But this time, when I'm doing that, it's going to be catching with the hand as well, and it should hopefully be a lot more precise, and I should be able to see what's going on a little bit better there. And also, now that I've got all this logging stuff set up, I'll be able to just replay it back and just see what happened before, so that rather than just like doing a bunch of runs and like trying to vibe it, pretty much, which is what I was doing earlier. Okay. Yes. So, putting it all together, does it work? Let's see. Alright. So, what have we got? We're going to turn Jugglebot on. So now, we should be able to... Our timing of the ball dropping should be fixed. We'll see. My conductor's wand should work, so I should be able to move Jugglebot around with my conductor's wand. And we should also be able to put a ball in the dropper and then have Jugglebot move to be underneath the ball and then catch it. Let's test these things. We don't actually need to do the conductor's wand, but I want to do it because it's cool. It's weird. It's very strange to be able to move the... I'll show you when we're there. All right. I don't know what you guys should see. Do you want to see my... Oh, no, I've got... That one. Yeah, and then... But let's put me like over here. And let's make this big so it's higher quality. Nice. I feel like the right hand's... yeah, this side is actually going to be better. Just give me 1 second. There we go. Okay, cool. Alright. So we can boot Jugglebot up. I don't think it will need to go through its homing sequence and everything because I haven't unplugged it. Yep. It's all on. Ready to go. Take the ball out of the hand. So, yeah, I'll explain something in a sec. Let's activate the robot. So it should lift up. Bum, bum, bum. Nice. And now we can put it into catch dropped ball node command. The naming... I've got a bit to say about the naming. What? Why are we getting an error? I haven't changed anything. DQ index out of range. Oh, alright, hang on. We got to do some debugging on the fly here. Oh, actually no. Alright. If I just keep this in the... Hang on, is QTM on? Yeah, it is. Alright, if I need to keep the marker in the view of the robot. In the view of the cameras. That is a silly error though. I should fix that. Get in there. It's kind of annoying. I've got to hold it with my right hand, but I'm right-handed. It's hard to use the keyboard. Alright, let's try this again. Catch dropped ball node. If it'll get there. I still haven't properly... Oh no! Alright, let's do some real-time error correcting. Alright, let's put me, you can... Okay, so what do we got? This should be easy to fix. I think I know what's going on. In catch dropped ball node, we have line 409. Huh? Where is this? Interesting. Let's just do... that. Thank you, GitHub Copilot, my hero. Alright, this should work now. So what was happening is I have a list of all of the coordinates of where the ball is supposed to be, but if that list is non-existent, then it would throw that error. But now we have a check for if that list is non-existent, and it should just quit. It should just like do nothing, basically. Alright, hopefully this works. Okay, let's go back to this. And now, catch dropped ball node. Oh man. This was working last night. Alright, I'm going to have to show you next week, I think. That's so annoying. Why is this happening? Catch dropped ball node. Let's turn it off. Maybe if we've got time at the end, we can debug this a bit more. The pose field must be... Oh. Alright. Let's say... Yep. Alright. I think we should be good now. I want this to work. Oh, you couldn't see what I was doing then. God, managing all the cameras is not trivial. Okay. So now, Yes, we're in. Cool. All right. Yeah. So let me... It's so sketchy bringing the marker in and out because it tries to follow the marker straight away. Let me just move the tripod because it's kind of in the way there. And then we can... we can... We can conduct Jugglebot to move around. Yeah, so as soon as I bring this into like... So I have a check in here so that like if I'm... Okay, I need to check my checks a bit more. I have it so that it's like clipped to, like if I have the marker like way outside of where Jugglebot can reach to, it will clip so that it doesn't just like destroy itself trying to reach out to like where I am standing now. But because it's tuned to move kind of quickly, it does mean that when I'm like entering the marker into Jugglebot's workspace and like pulling it back out again, it tries to like follow it the whole way to the very edge. And that makes me very uneasy. Yeah. So it's pretty close. Like I don't know how well you can see the marker in the camera view, but it's pretty good. And like so, right now, like Jugglebot will stay the same height. So no matter where I put this up and down, it will still follow it. Until if I go like below the catch plane, it should ignore it. Actually, maybe that's a good way to go in and out. But like, I have to go like up and over the carbon fiber rod. So that's not gonna work. Yeah. This is very fun. Yeah. And then if it loses the if it can't like reach the marker after like a second, it will just return back to its normal position. Cool. So that's all fun, but that's not catching yet. So let's try catching. So to do that, we need to put the tripod back kind of in position. It just needs to be somewhere that the platform can reach over to. I can load the ball in. And I'm actually going to bring my keyboard over with me because every time... So once it's tracking the ball, if I cover up... If I block any of the markers that are on Jugglebot's base, then what will happen is the system will like adjust where it thinks Jugglebot's base is based on the number of markers that it actually has access to. So like if there are 6 right now, if I'm blocking one of them, it will just use those 5 to figure out where Jugglebot's coordinate frame is. But every time that shift happens, it kind of moves the frame around a bit. I probably should add in some kind of filter on that, so that like a low pass filter, so that where the system thinks Jugglebot's base frame is, so that can't change very quickly, because I'm never going to be moving the base more than like a couple centimeters a second or so. So it should not be able to assume that that's changing really rapidly. I do need to fix that, but what that means is that if I have the ball in view of Jugglebot, like in the gripper, and then as I walk around, the position of that ball changes with respect to what the system thinks Jugglebot's base is, and the whole platform just kind of moves around like crazy. So I don't like that. So I'm gonna make it so that I don't need to walk around too much, which means you're probably actually not gonna be able to hear me very well. But I will just avoid talking, and I'll show you rather than tell you. Yep. All right. Wish me luck. What is it doing? We've got erroneous markers in here. Okay, so something that I'm doing here is I'm assuming that there's only one marker in view, and that one marker is always the ball. And it's just taking the first... So like whichever the first unlabeled marker is the ball. And it looks like something else is being detected. let's just exit this mode and then re-enter it. So I've got this set up so that if I give it like a bogus command of like nothing, then, or like if I have like a typo or something, then it should return to the standby mode and collapse itself down. All right, so let's now go back to catch dropped ball node. Oh, so actually we need to activate the robot first because it's currently inactive, or idle rather. All right. Yep. Catch dropped ball node. That should move. There we go. Alright, so now it's tracking the ball. And you'll see what I mean when I walk past. It will kind of skits out a bit. That's okay. Ah, that time was alright. Yeah, so to make sure it's working, I can move this around. It looks pretty good. Then you can prime the hand. So it raises up. It's ready to catch. Moment of truth. Let's try that one more time. It's always a bit sketchy getting the ball out. I could definitely do with some more cameras to get better tracking so that I can't block it as easily, but you know, is what it is. Alright, let's prime the hand again, and let's just double check that everything's working. Yep. Come on, up you go. Ooh. That's interesting. Okay, I need to fix my code because apparently it doesn't move while the hand has been primed. So now I've moved this a bit. I don't know if that's going to be lined up. We can try it. So we still have, as you can see, we still have the same problem from before where the timing is not right. And let's shut it all down. Yes. Some more work definitely needs to be done, but it's getting there. It's still not perfect, but yeah, we're getting there. I'm getting there. So some known problems. I guess, yeah, I didn't realize that the when the hand has been primed. So yeah, what's going on there is there's like one module, the catch dropped ball node, that does all of what I just showed. Like it makes the platform track the ball, staying horizontal at a fixed height, and then it also, when I send the prime command, the prime hand service, it will raise the hand up and get it ready to catch. And then once a drop has been detected, and this works the same way as what I showed last week, once the drop has been detected, then it will move the hand to catch the ball. I didn't realize that when I haven't really tested this very thoroughly. I only got this working yesterday. I didn't realize that when the hand is up, the platform should continue still tracking the ball, just with the hand up and ready to catch. But it turns out I've done that in a blocking way, and so the hand being up, waiting for the ball to drop, while it is waiting, it is apparently, well, it turns out that it is blocking, and so they can't move the platform around as well. But a bigger issue than that is the timing one. Like, it's still, the timing is still off by what looks to be a very similar amount to what it was last week before I added that offset. But now I've done that code correctly, so I think. So, like, I've done that equation at least correctly, so now we're actually getting the time it takes for the ball to drop from, like... Oh, I think I know what the problem is, actually. Alright. So that equation that I'm using there is to figure out how long it will take the ball to drop from the dropper down to the catch height. I need to check this, but I haven't actually updated that. I haven't deliberately changed that catch height from when I was doing the testing last week, which involved not having the platform raised. So last week when I was doing all of this testing, the platform was just sitting like as low as it can possibly go. and I just aligned the tripod to be in the right spot, and then I was only having the hand contribute to the catching. Now the platform is raising up by like 170 millimeters, I think. No, more than that. It's raising up by some amount. I can't remember exactly how much, but it's raising up, and then it's possible that the time taken for the ball to drop is still being calculated based on the hand being, like, based on the platform being all the way down. I reckon that's probably it. I hope it is, because that's going to be really easy to fix. So that would be very nice. But in any event, yeah, the timing is not perfect. There's still some work to be done on that. But overall, it's decent. It's getting there. And also, like, that tracking problem of, like, the marker not being where I think, like, the platform not lining up perfectly with the marker, bit of an issue. But we're getting there. Yeah. Honestly, that big, like, yeah, no, we're getting there. Cool. Okay. So one question that you may have in your mind is that recently I've been doing a lot of talking about active catching and passive catching. And right now we're trying to follow an active approach where we are figuring out exactly when the ball is going to be landing in the hand, and we're having the hand follow a trajectory that will have it pretty much perfectly catch the ball in the hand. By the way that it does this is the hand tries to match its velocity to the incoming ball as closely as possible with, like, I've set it to be, I think, like 80% of the ball's velocity at this point, but it gets pretty close to how fast the ball is going, and that way it should, if we could play this back in slow motion, we should be able to see the ball land very gently, smoothly in the hand. That's what I'm referring to as active catching. The hand is actively moving in anticipation of the ball coming in to receive it. On the flip side of this, I've been pretty strongly, I've been feeling pretty good about the possibility of using what I've been calling passive catching, where when the Jugglebot is expecting a ball to come in, like when its next event is going to be a catch rather than a throw, when its next event is going to be a catch, it just sits at the very top of its stroke. It has the hand sitting at the very top of its stroke in a configuration that is sufficiently spongy or, like, I don't know, easy to move. The intention there being that when the ball comes in, even if the timing is not quite right, even if, like, it doesn't land in exactly the way that we expect it to, the intention is that the hand is sufficiently low inertia and, yeah, spongy that when the ball comes in, it can just push the hand out of the way. Kind of similar to what it would be like if you were to catch, like, a cannonball or something. Like, your hand is not going to do anything to, your hand is just going to get pushed out of the way, but if it's not moving too fast, and I don't know, if you're sufficiently prepared for it, you would be able to slow it down and stop it before you drop it or it hits the ground or anything. So that's what a passive catch is, that it would just, like, automatically do that catch. It doesn't need to follow any particular trajectory or anything, it just goes. However, these things are not mutually exclusive. We should be able, if I'm on PowerPoint, we should be able to combine the two together and have active and passive catching. And what this could potentially look like is to move the hand a fraction of how fast the ball is moving. So, for example, it could be anywhere from like 25 to 75% of the ball speed, which is very useful because it means that the hand will take less time to cover the whole stroke. So, yeah, it will take less time to accelerate up to being at this speed. It will also be at that speed for a longer duration, and then it will decelerate faster as well. So it will basically be in, like, a catch-ready position for a lot longer than if we're doing a full active catch. Because if the hand is fully matching the speed of the ball, then it's going to cover its entire stroke very, very quickly, in like 200 milliseconds. But if we can make it move more slowly, then it can be in that catch-ready situation for a lot longer. In addition to moving the hand more slowly, so that the ball doesn't just bounce out of the hand, which is an assumption that I'm making at this point, that it would do that, and we can talk about that. But with that assumption, in my mind, it seems like it would be very useful to have these spongy gains while the hand is moving down. Now, I think it's going to be a bit of a balancing act between having those gains so low that the ball can actually make a difference to the position of the hand, versus having them too low, and so that the O drive can't even move the hand at all. Like if those gains are really, really low, then it's going to be sending out commands saying, hey, move here, move here, move here. But the amount of like friction in the system is not going to let the thing actually move until the amount that it needs to move by is like sufficiently large. So it's going to be a bit of a balancing act to get those gains tuned perfectly. But I think that this could work. Yeah, I have high hopes, and thank you to Craig and John for the discussion on this. We had a short discussion, but still ongoing as far as I can tell, on Zulip, if anyone's curious to check that out. Cool. Yeah. Okay. So that is the main update, I suppose. But there are some other smaller, fun updates, I think. So we've got some good stuff coming. But I do need to change the camera then, and I need to have some water. Cool. All right. So next thing, this is a fairly short update, but I think it's useful. So I have updated my active states in my state machine. You may remember that I have a big... I'll show you rather than describing it. Why is there an exclamation mark there? So if I boot Jugglebot up, I'm not actually going to get it to do anything, but I just want to show you what this state machine looks like, because I have made some changes to it. So let's pull this in, get full screen. For some reason, I have to change this every single time. But yes, here is Jugglebot's current state machine, and the text is a bit small. Even zooming in doesn't help. Yep. But hopefully, I don't know, if you're on a monitor, you might be able to see these things. But the general idea here is that all of these ovals are different states that the robot can be in, and all of the lines show how these states connect to each other. And they also show the outcome that the state needs to have in order to move to each other particular state. So right now we are in standby idle. If standby idle has the outcome of activate robot, then we will go into standby active. And then from there, we can move into all of the other active states, which right now are Space Mouse, Shell, Catch Thrown Ball node, which should be interesting when it works, and then also Catch Dropped Ball node, which is the one that I was just doing then. And all of these states, yeah, this is like a map of where Jugglebot can, how Jugglebot can be currently configured. Yep. And I have changed, let me just put these things back. Dun, dun, dun. We can turn Jugglebot off again. No more fan noise. Yeah, I can change, I have changed how I'm creating these active states. The reason why I have changed this is because before, when I only had a couple active states and I wasn't really adding to them very much, I did the quick and dirty solution, which was to just have every place where I needed to describe these states, I would just list them out. And so this is one example of where this comes up, is that in this state machine library, the way that you actually initialize these states in the first place is you have this add state method where you describe what the state is called, you give it a particular type. In this case, all of these are generic active states. And then you also describe the transitions. So from the Space Mouse control state, we can move into all of these other ones based on these outcomes. So the way that this transition map works is, yeah, the first word before the colon is the outcome that needs to happen in order to move to the other state. So on the right-hand side of the colon is the state that we're moving into as a result of achieving that outcome. And every single time I made a new active state, I would have to copy paste this code, and then also in all of the other ones I would have to add in here, like when I added in my catch dropped ball node state, or whatever I call it, I would have to add into every single one of these other ones catch dropped ball node colon catch dropped ball node state, or whatever they were called. and I would have to update every single one of them. And that's obviously, why is my eraser not working? There we go. It's obviously not a very future oriented solution, not very long term. And also, like, this isn't the only place where that happened as well. There were like 3 other places where I would have to update that list, and it's just a pain in the bum. But now, haha, improved, it's just a single list. So now at the start of my state machine code, this is all in Yasmin state machine as well, if you're curious. I've finally pushed my last like 2 weeks of code onto GitHub, so it's all up to date as of this morning. Yes, if you're curious, this is in Yasmin state machine. But yeah, at the top, I just have this one list of all of my active states that I've got. And then this method here, build active state transitions, will create this mapping between where we currently are and where we can be next. And this is just so much nicer. This means that if I need to create new active states, I just need to add a new line in here, and that's it. Everything else just works. So good. Big relief. One kind of funny thing that was driving me mad a little bit, and I had to go back and change a bunch of other code to make this work, is that the outcome, so again, here we have the outcome is the first bit, and then the state that we're moving into is the second bit. And because of the way that the Yasmin state machine works, the outcome has to be a different string from the mode name that we're going into. And this is case insensitive. So what I was hoping to have is I would just have, if I want to move into standby active, well, let's have the outcome be standby active in lowercase. So we can have lowercase is the outcome, and then the actual states, all of the states are full uppercase everything. So we can have lowercase outcome, uppercase state. But that doesn't work. It actually, well, that's not true. It does work. It runs fine from what I can tell, but the viewer, the thing that I just used to show you that state mapping, like that network, that viewer gets confused and apparently doesn't observe case at all and doesn't look at that and just gets really confused. It's like, hang on, you want to map between a state and a state, or like an outcome and an outcome? Like it doesn't realize which one is the outcome and which one's the state. So they all have to be different, completely different strings. This is why I've got this like underscore command for all of them as the outcomes. It's, I don't know, not as elegant as I would like it to be, but this is still a shitload better than what it was before. So we're getting there. All right, cool. Next thing, which is a fun one. I would like to have I would like to improve the dropper that I'm using here. So this, let me just grab it again. Whoa. Brought the end of the tripod with it. That's on there. I'll get that off later. Yeah, so this is my dropper as it is right now. It's very, very, very simple. I just pull these 2 top bits apart and then balance the ball in there. It can move around and it can be clamped in the wrong position and it's not super precise, but it kind of works. And then when I drop, it drops. And I don't know if that came up on the camera very well, but sometimes it doesn't drop perfectly straight. It's like then, I don't know if that came out, but like it dropped and like rotated down. One side will drop before the other side. And it's just not super repeatable, super reliable. And also I have to be over there and trigger it myself. Getting the ball in is a pain. It could definitely do with some improvements. Yes, so last week I mentioned that I had like I don't know, if anyone's got any ideas, then I would love to hear them. Same thing applies this week, but now I have some cool footage to show you of how someone else is doing this. So Kai is this guy in Germany who's doing his PhD on a juggling robot. I've mentioned him a couple of times, but I've never actually shown anything of his. But now I can. So I have a clip from our conversation that I would like to show you of his dropper. So so let's go here, full screen. Everyone meet Kai. So that last is very cool. Very, very, very cool idea. That last bit is where my hesitancy came up a lot, which is that I don't really want to have to be climbing up a ladder all the time to get the ball in. And also it's kind of, I would have to do some more modifications to my room to get that to fit in the roof. But he also sent me, whoops, another video of this in action. So let's watch this. I don't think there's any sound with this one. Oh, maybe there is. Yeah, so you can see it like really quickly like snaps over, grabs the ball, and then drops it out. And it's pretty fast. I'm fairly sure he's using stepper motors for these, and so it would be like very repeatable and very accurate. And he's even improved his setup. By now, he doesn't need to climb up the ladder anymore. He's just got his long grippy pole, which is, I imagine, a big quality of life improvement. Yeah. And then, yeah, so that last one does balance that. I was a little bit unsure of how that worked, but yeah, this is a very useful video to see how this is all, how it all goes together. Yeah, very cool. It's a cool idea. I do wonder though, like, can this be done more simply? Can we do it with only one motor? Like, I don't know, how could it be done differently? I was thinking of, rather than having like that long pole to replace the balls up the top, maybe it would be possible to have, I was thinking of the Winter Garden project and how he's got those like conveyor things, like the, I don't know how to describe it. It's like a rail, like there are two wheels that spin and they lift up like a belt, and on that belt are little cups, and those cups like hold the balls as they go up. It's not, it's kind of along those lines. And I was thinking like maybe I could have like that sort of thing down on the side of the wall there, and that way I could just like plop balls in on the side, and then they can get lifted up by this conveyor thing and then roll down the little channel and then into this dropper sort of mechanism like what Kai has. That does feel a bit overcomplicated, but in any event, something to drop the balls down would be, so that I can activate it from a distance, would be so nice. And yeah, I honestly, Kai's design is the best one that I can, it's better than anything that I have been able to think of so far. But if you have any thoughts, then I would love to know. As few screws needed in the ceiling would be good. I am renting here, and I don't want to add too many more holes. I've already got quite a few. Yep. So yeah, any thoughts? Very welcome. One other quick update is that I have kicked yet another marker in my testing yesterday, and like going around like heat shrinking all of the cables that had come off. Apparently I didn't even notice doing this until later on when I was like doing a run, and I saw in the tracking software that this marker was a little bit off. I'm like, hang on, what the heck? Why is one marker off? Thankfully, it's holding on just by a thread and has not actually come off yet, so I've just kind of like bent it to be straight again. So it seems to be working, but it's definitely like, it is just barely hanging on. And it's also kind of annoying, actually. If anyone's got any thoughts for this, I would love to know. This happened with the other one that I kicked as well. You can see in this hole, maybe I can actually zoom in. There's a little bit of 3D printed screw still in here, and I don't know how to get that out. So like on this one, when this fully breaks, what I did for the other one that broke is I just moved the marker to a different spot. But I don't really want to have to keep doing that, and eventually I'm going to fill up all these holes with little printed bits. So I don't know if anyone's got any ideas for how to get that out. I thought of like maybe drilling it out, but there's threads on these parts are threaded, and I don't really want to stuff up those threads. So I don't know. Yeah, it's tricky. And yes, so the aluminium replacements for these parts cannot come soon enough. I am very eager for them to arrive. And to be honest, I think, so I mentioned, I think last week, that I've put in an order for a bunch of these like replacements of that printed part, and I've bought 10 of them. Well, I've ordered 10 of them. Right now I'm only using 6. I have a sneaking suspicion that using more might actually help with a couple problems that I've got. One problem is the markers, like what I described before about like when I move the conductor's wand around, Jugglebot's hand does not perfectly align with where the marker is. It's offset by a little bit. I'm thinking that maybe that might be happening because the positioning of where Jugglebot's base is might not actually be perfectly correct. We only need a minimum of 4 markers to get that positioning correct. So I figured that 6 is a bit overkill and would be super accurate. I think adding more couldn't really be a bad thing. I think, as far as I'm aware, there's not really going to be any drawbacks to using more. So I'm thinking that once they arrive, I'll just use all 10, and hopefully that will fix this tracking problem. It will also hopefully fix the issue that I described before but didn't actually happen, where when I walk around and the number of markers on the base that are tracked changes because I'm blocking them, then that changes where the whole base origin is and just makes everything kind of go funny. Hopefully, by having more, it will mean that if I block like 1 or 2 of them, there'll still be like 8 left that will still give a good, solid estimation of where Jugglebot actually is. Hopefully. We'll see. Cool. Next thing. There's one more fun one after this as well, a very fun one that I'm very keen to share. I've been thinking about it a bit. But before that, another question is how to track the platform. So right now we have the 6 trackers on the base, and those are basically these little balls. Instead of the little black footing thing that's on this one, there's an M4 thread in these, and so I've just gotten an M4 bolt, chopped the head off, and screwed it into both sides, and that way I can screw it into things. And that's it. I don't have any other trackers on Jugglebot anywhere. But I would like to be able to track the platform, because I think if we knew where the platform was in space, that would it would help answer a lot of questions about where things actually are and like what's actually going on with this tracking data. But one of the reasons why I haven't really moved too far forward with getting the platform or even the hand tracked is because I don't know how to put these markers on the platform or even the hand so that they are not breakable, basically. I've got big markers and small markers. Both of these work completely fine. But my fear is that no matter how I put these on, some ball can come along and whack them. And I've learned from experience that once I've got like a rigid body set up, so like there'll be in the end, there would hopefully be a rigid body for Jugglebot's base, a rigid body for the platform, and a rigid body for the hand. Once I have those rigid bodies set up in my motion capture software, changing them is a bit of a pain in the ass, and I don't want to do it all the time. Like if the markers move a little bit, I would have to either put the marker exactly back to where it was before, which would be tricky, or reset those rigid bodies, and that's not very fun to do. I don't want to have to do that. And I haven't been able to think of a good way that I can put these markers on the platform so that they are immune from being bumped and also visible to the cameras. Like there's plenty of space like underneath various things where there's like no ball. It's pretty unlikely that a ball is ever going to hit that, but it's also pretty unlikely that the cameras are even going to be able to see. So I got to thinking, like, maybe we actually don't need to use these markers. Maybe instead we can use the tape. So I'm using tape to cover these balls. These balls are normally, some of them are white and some of them are green, but you can't tell because they're covered in tape. I thought maybe I can use that tape to just put like little bands or circles onto the platform. And that way this can get whacked with balls as much as I like, and the ball's not going to do anything to the tape. But I wasn't sure if this would actually work or not, and so on the rear end of my conductor's wand, I've added a thin strip, a thick strip, and then 2 circles of different sizes. And that way we can go into the tracking software and watch as I move them around. And we can see they're pretty good. Like I can move this into a bunch of different orientations. Like if I go really like oblique, so that it's only looking from like a really steep angle, like this sort of thing, then it doesn't do so well. But to be honest, I'm very surprised by how well this works. Like all 3 of them are tracked without much problem at all. And this is a very good sign in my mind. I'm thinking that I can just cover the platform at various spots in these little strips of tracking tape, and that way I can make that one rigid body one time, and it'll be fine. It'll just be a bit stripy. So I think that should work. If anyone's got any other thoughts, I'd love to know. Sam Certified says, lifting up the balls with an Archimedes screw might be simpler than a conveyor, although even that might be overcomplicated. Does that work when it's not completely full though? So like, one advantage I think of the conveyor belt solution is that I think it's less prone to jamming up, and also it allows for there to be like it allows for like booms and busts in terms of the number of balls coming through. Like with the Wintergarten's marble machine, he can have like a big stockpile of marbles that are ready to be taken up the conveyor belt. But then also if they're all at the top already, then the conveyor belt can keep running and it will still be able to lift up errant balls that come through every now and then, but it doesn't require that there's like a steady flow of balls to be lifted up. But I think an Archimedes screw, I think to lift balls like this, I think it would have to be the screw surrounded by like a PVC tube or something, some kind of tube, and then there would need to be like a constant supply of balls to like come in to then like push the upper ones up. Is that correct? Can it just lift to like one ball? I don't know. Yeah, I do. To be honest, I think that both of these are a little bit overkill. Like, I am tall, so maybe I could just reach, but I don't know. I could just throw them as well, maybe. Honestly, that could be a good solution. Like, if there's just like a big enough funnel where I can just like toss the balls up there, then I feel like I'd be pretty happy with that. But yeah, I think that the dropper is definitely a bigger point of interest for me. Like something that can reliably drop the balls at like exactly the right time that I want, always dropping it perfectly straight down. Yeah. And it's like, and can like self reload. Yeah, would be very nice. Okay, so I believe last thing, yes, Bongo Jugglebot. All right. Before I describe this, I need to have some water. You can think about what this might be. So, for quite a while, I've been thinking of ways to control Jugglebot and to juggle with Jugglebot, but have it not with in the sense of like a partner juggling, but juggling so that like you as the human are controlling Jugglebot and you're juggling kind of like teleoperatively, like how all the Tesla robots are being moved around now. They're not doing that by themselves. There's like a person somewhere that's like getting them to follow those movements. And I've been trying to think of ways to do that. So like for example, if you were in like a wheelchair and like one of the contexts I've been thinking about this in is like if I got hit by a car and like lost utility of my legs, that would be kind of annoying to juggle. But if there was some way that I could control Jugglebot, then I could like juggle with Jugglebot being my arms. And the first way that I was thinking of doing this is to use the space mouse. So like get something like this where you just like move the puck around, and then something where you can like hit a button, and based on how hard you hit that button, it will throw to that height. But honestly, I think that if once Jugglebot's working, I'm definitely very keen to have that sort of control method set up. But I really doubt that that's going to be possible at all. Controlling it that precisely is so hard that I don't think that's going to work. Let alone like throwing repeatedly high. And so that kind of like nipped that in the bud for me. But I was like, there's got to be some way, some like cool, fun way to control Jugglebot as the human, so that the human is kind of doing the juggling, but also not needing to be robotically precise. And I think I've come up with it. Well, one option at least. And I think the way that this could work is, let's say you have 2 Jugglebots. I think it would be better with more, but minimum would be 2. And you have a bongo in front of you. And when you hit the bongo, it will throw a ball. I don't know how it would decide on the height. I think it would just pick, like, it was, let's say like a default height of like a 5 throw. So like maybe 1 meter to 1.5 meters. And then it would adjust the other heights accordingly based on when you hit the bongo again. So if you just like whack the bongo randomly, it's going to throw balls whenever it can, so that it like throws to the other hand or throws like a self throw or whatever, whenever it can in time with your hits. But if you hit it really fast, obviously it's not going to be able to throw balls that quickly because it just won't have that many balls, and so it will miss a bunch of the beats. But if you can get the timing perfectly, then you can get some patterns emerge. And so if you get the timing really well for like 5 balls, then it will be juggling like a nice perfect 5-ball pattern. But then if you suddenly like speed up a little bit, it might start throwing them a little bit lower, so they're going faster. Or if you speed up enough, it might decide to chuck in 2 more balls and then go up to 7. And like, I feel like this would obviously require a lot of, like, all of the decision-making stuff here will be done by the robot. So that, the whole control side of this would be a lot of work to get working, but I feel like it should be possible. And I think in the end here, if we had like a whole array of Jugglebots, you could just sit there with your bongo and find new patterns. Like if you get like a nice steady pattern emerge, well, a nice steady beat emerge, then the Jugglebot system, the troop, can create a pattern that matches with your bongo playing as in time as possible. And like that way, yeah, I feel like it would just make really cool, very, very cool patterns. I think it would be a lot of fun to play around with. Maybe like how hard you hit the bongo makes it throw higher, at least to start with. I think there's a lot of possibility here. I absolutely grant that the control side of things is very, 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 very complicated to get that sort of thing to work. But I do think it would be possible. And I think it would be so much fun. Anyway, yep, that's just a random thought that I've been having for a couple of weeks. And I wanted to get it out there, you know? One day, this is going to be a thing. And we're going to be able to look back to this stream in 2025 and say, yes, this was the public origin of this idea. Yep, one day. Cool. Okay, yeah, so lots of things to work on. Thankfully, there are no looming bugs anymore, so I'm very relieved about that. I have a good feeling that the timing of the catch is just related to that height offset. I really hope it is, because that's going to be so easy to fix. And to be honest, I think we're pretty close to getting partner juggling working. Once... There are obviously, like, I don't know, some steps to go through first, but in the abstract, I think it's pretty close. Like, if I can drop a ball and have Jugglebot catch it, then I can just set up Jugglebot to then immediately throw that ball up to the same height. And then I can do the same thing. So it will be like partner juggling 1 ball. So it'll be doing this kind of thing. And I feel like once that's working, it's not that far to go, okay, rather than me drop the ball, let's instead put my hand over here and I can throw the ball. And I've already got the code set up to like find the path of the ball and figure out where it's moving and all that sort of thing. And it should be able to have me throw a ball in. It will catch the ball and then toss it back in the exact same path that it followed before. And it's going to be a bit of work, I think, to get that to then build out to do multiple balls, but not an impossible amount. So I feel pretty good about this. And also, actually, one final thing is just like on why I'm so interested in this partner juggling at all, because really in the end, Jugglebot's just going to be juggling to itself, because the human is going to become the weak point of the system, and there's going to be no reason to include the human in there anymore. Except for fun, which I guess is his own reason. But I think at the beginning... I think that the partner juggling is useful in the same way that it's useful for humans. So what I mean by that is if anyone watching has tried to learn to juggle and has failed, and has, well, not failed, but like hasn't learned to the satisfactory level for them, one strategy, the single best learning method that I have ever encountered for learning how to juggle, is to partner juggle. So you stand with one arm behind your back, you get 2 people. Ideally, one person already knows how to juggle, but it works even if both people don't. Like you can get 2 people who don't know how to juggle and they just learn together way faster than they learn by themselves. The way this works is you stand side by side and you have one arm behind your back, like the arm that's like in the middle. So like in this case, it will be my left arm, and the person next to me will have their right arm behind their back. And then the arms that are not behind your back become the arm of the collective person that is doing the juggling. So I would have my right arm will be the collective person's right arm. The person next to me will have their left arm. And we throw, so I would throw to their left arm, they would throw to my right arm. And that way you only need to focus on one hand at a time. You can just watch their ball coming in, just focus on your one hand, and then get your ball out before their one comes in. And then once you get familiar with that, you can swap sides and do the same thing on the other side. And honestly, most people can learn this way, especially if they're learning with someone who already knows how to juggle. You can learn how to do 3 balls in like 20 minutes if you do it this way. It's unbelievably fast. And I'm thinking it could be similarly useful for Jugglebot to do this with me, so that I can kind of tune, so that I can get a feel for like how it is behaving. I can basically, like, if I am Jugglebot's partner, then I will be able to compensate for errors that Jugglebot makes, so it won't need to be as precise as it would need to be if it's only juggling by itself. And that way, like, yeah, I can compensate for things, and together it should work. And then over time, as I tune the robot to be better and better and better, eventually it will be precise enough that it can just go by itself, and then off it goes doing its own thing. So that's the main reason why I'm so focused on getting partner juggling to work, is because I actually think that it's going to be one of the quickest ways forward to get Jugglebot to juggle by itself. And also, a little bit, the cherry on top is that it would just be so sick to juggle with the robot. I think this is going to be a lot of fun. Yeah, and we're almost there. We're getting there. All right, cool. So that's everything. Hopefully next week we've got some nice smooth catches. I have a good feeling about it. I think it's coming along. Slowly. We're getting there. Cool. All right. I hope you found that interesting. As always, any thoughts, very, very welcome and appreciated. And yeah, good luck with everything you're doing. And I will see you next week.